Hello and welcome to NASA Science Live, an opportunity for you to come behind the scenes and to get to know your space agency. I'm your host, Sophia Roberts. This show gives you the opportunity to ask NASA scientists questions and then to get your questions answered. So visit us on Facebook or Twitter and ask us a question using that hashtag AskNASA, or leave a question in that comment box wherever you're watching this. But first, here's some of the latest news from around the galaxy, brought to you by our cosmic news anchor, Scott Bednar. Scott, what have you got for us?
Thanks, Sophia. Happy Earth Day, everybody. I am Scott Bednar, reporting live from the Cosmic News Corner, and have I got some news for you. History was made this month when the first ever image of a black hole and its shadow was unveiled to the world. The photo may seem a bit blurry, and you may be saying to yourself, did I just get catfished by a black hole? But rest assured, you did not. This is a really big deal. We've known for some time that black holes exist, but we've never actually been able to image one. Perfect for scrapbooking. It took 8 radio telescopes from around the world working together as one giant Earth-sized telescope to be able to construct this image. Conversely, the unsanctioned dictionary of non-scientific terms defines black holes as what you get in black socks. Moving on, new findings are helping scientists understand the history of water on our moon. Put your bathing suits away. We're not talking swimming holes, just little wisps of H2O. NASA's LADEE mission has discovered that water is being released from the moon during meteor showers. Let me break it down for you. A speck of comet debris strikes the moon. It vaporizes on impact and creates a shock wave in the lunar soil. When something larger than a speck strikes the moon, this shock wave can breach the soil's dry upper layer and release water molecules from the hydrated layer below it. For those of us without PhDs in geological lunar impact modeling and analytical physics, there's water on the moon. Have you heard? NASA is sending a helicopter to the red planet. Let me repeat that. A helicopter to Mars. Now, this isn't your everyday run-of-the-mill helicopter. With a body the size of a rolled-up guinea pig and twin rotors almost 2 meters wide, this helicopter just passed its final flight test here on Earth. So the next air this mini chopper chops will be in the thin atmosphere of Mars. Look, we've sent orbiters to Mars, we've sent landers, and we've sent rovers. But think of what would be possible from the air. NASA's really taking science to new heights. Meanwhile, it's Earth Day. Have you thrown away all those plastic straws yet? How about planted a tree? No? Well, I've got just the thing to make you feel better about yourself. NASA invites you to take a picture of your favorite natural earthly feature and post it to social media using the hashtag #PictureEarth. It could be a setting sun or a blooming flower or a pile of dirt. NASA's going to take these pictures and turn them into a collage of legit proportions. But I still encourage you to take care of our Earth every day, and maybe go ahead and plant a tree. Well, that's all I've got from the Cosmic News Corner. Hungry for more NASA news? Of course you are. All you have to do is tippity-tap nasa.gov into your phone or your sit-down computer, and a world of science will emerge in front of you. Check it out. You might even learn something. Back to you, Sophia.
Thanks, Scott, and happy Earth Day, Earthlings. Today's episode celebrates what makes our home special and weird. As Scott just mentioned, we've been asking you to send us pictures of your environment using the hashtag #PictureEarth. There are already a ton of submissions, including some from other NASA missions, that show how they hashtag #PictureEarth. So take a look on social media, and there's still a time for you to submit your own picture. So during today's episode, we're going to talk about some of the features that make our home weird, how we study our planet, and where we might see these special features elsewhere in the solar system. So remember to submit your questions throughout the show using that hashtag AskNASA. But before we go any further, let's take a look at how Earth is unique.
Earth. Home. Of all the planets NASA has explored, none have matched the dynamic complexity of our own. Deserts, tropical forests, icy poles, massive storms rage over land and oceans. A unique atmosphere protects and insulates us. Liquid water spans its vast surface. And a delicate balance of systems gives way to a kaleidoscope of life. Earth is a very special place. From the vantage point of space, the perspective of sky and sea, and all across the land, we study our planet not only to learn about it, but also to protect it.
Earth is There's an active, moving core, a magnetic field that protects our planet, a delicate atmosphere and fresh water that moves throughout the land and the air. And then there's the weirdest of all, us. So there's nowhere else in the solar system and beyond where we have found life other than our home planet. So, speaking of life, I am joined by 3 experts who are going to help us dive into these topics. We have with us today Anne-Marie Eldering from NASA's JPL, who is working on the Orbiting Carbon Observatory. We have Jim Garvin, who is Goddard's chief scientist, and we have Alicia Joseph, who works on, or is a research scientist here at Goddard. So Earth is special really in so many ways. So I'm going to start with you, Jim. How did we get water on our Earth?
So our planet was born in a magical mystery tour 4.5 billion years ago when it came together. It formed hot. But as it formed, it was collided with by the leftover remnants of all the stuff that made our solar system. Some of these things were water-rich, comets. They seeded our planet with initial water. And then, as the Earth cooled down, volcanoes erupted, releasing even more water. This water cycle thus began, and it evolved over time to even affect the rocks we live on today on our continents. We are the water planet.
Ooh. And Alicia, how does our water move through our atmosphere?
Well, the hydrologic or water cycle is a fascinating process which describes how water moves above and below the Earth's surface. Water moves from one reservoir to another. For example, ice, fresh and saline water like oceans, lakes, rivers, and aquifers, and the atmosphere by the physical processes of evaporation, transpiration, condensation, precipitation, and surface runoff. In doing so, water goes through various forms, like ice in its solid state, liquid, and vapor in its gaseous state.
Yeah, that is really special how our water is capable of moving. And one of the places is through the atmosphere. So, Jim, can you talk to us a little bit about how our atmosphere has formed?
So our planet's special because it's big enough to retain an atmosphere. So after the Earth formed, it started to cool down, the oceans were being accreted, the volcanoes and other things in that part of the Earth history released gases. And they slowly built up over time and were affected by our planet, slowly initially, and then eventually by the activity of life. And that's one of the key ingredients that makes our planet's atmosphere so unique.
Yeah, no, our atmosphere is just perfect for us, right? It's got about 21% carbon or oxygen, and that's what we breathe, a whole lot of nitrogen, and there's many other gases in trace amounts. Just want to tell you quickly about 2. One of those is carbon dioxide. It's like a little blanket. It keeps heat in our atmosphere and makes the temperature what it is today, very comfortable. But carbon dioxide's been going up in concentration, something we got to keep an eye on. Another gas you might know about is ozone. It can be a pollutant, irritate you when it's down low in the atmosphere, but if it's high up in the stratosphere, it protects us from UV radiation. So Jim and I don't freckle too bad because that UV radiation's stopped by the ozone.
Thanks. Anne-Marie.
So one of the things that I don't personally think about originally when we talk about the Earth, but is super important, is on the inside, and that's our core. So Jim, can you please tell us about our Earth's core?
So our planet is special because we have a kind of sweet inner core, a solid, very inner core, and then an outer liquid core that moves. And by rotating, it generates a geomagnetic field. And that field, which is really critical to life on Earth, is the force field that protects us from all that nasty space radiation that if we were beyond it, we would be experiencing. So our Earth is lucky enough to have such an inner core. We look for such elements, such aspects of planets on other planets like Mars, where Mars Insight will be looking for the Martian core.
Great. Well, now's our chance to take some questions from you. So if you've been sending questions in, please remember to use that hashtag AskNASA. Go to Facebook, go to Twitter, use that hashtag, and leave a comment wherever you're watching if it's a streaming. All right, so let's see what we've got so far for our Ask NASA. All right, Vicky on Facebook is asking, how come Earth is the only planet that has water and oceans?
Well, I will say this. First, some planets and planet-like objects have oceans, but you don't see them at the surface. So, for example, one of the big moons of Jupiter called Europa, it's about the size of our moon, probably has a bigger ocean than Earth's under an ice shell. Other worlds hide their oceans. Mars, a lot of the water on Mars is frozen in the rocks and frozen as ice. So it's not exactly that all the planets are, you see what you get. So there's a lot of ocean worlds to go discover.
Excellent. All right. Manish on Twitter is asking, how many advances in space technology have helped us on Earth? Ooh.
I think the answer is a lot. I mean, I know there's insulating materials that were developed for space program that have benefited us in our lives. There's probably others you guys might know.
Geolocation and satellite navigation that we now use to precision go to places that we never would have imagined. Laser detection methods that we can use to figure out distances to things that eventually will be in driverless cars. And also things that sense perturbations in our atmosphere that affect our quality of life. These are all sensory things that we've developed in space.
Yes, and every day at NASA, scientists and engineers are continuing to push the envelope and to do research to get us further and to get more information.
Wonderful. All right, Patrick on Twitter is asking, what planet have we discovered is currently the closest in characteristics to Earth?
Well, it depends on how you look at it. So for me, that world would be Mars. Although it has less atmosphere, it's colder because of its position, it still has a history book written in the rocks that we're exploring now with rovers like Curiosity, soon a helicopter. So it really is kind of our Earth-like brother. However, don't forget Venus. She's hiding her secrets, and we got to get to know our sister much better.
Wonderful. So that is all the time we have for questions right now. Don't worry, we'll be taking more later on in the show, so please keep sending them our way and using that hashtag AskNASA or commenting in the stream wherever you're watching. So now let's talk about how we study Earth and why it's important to better understand the complex processes that work on this planet. Anne-Marie, you've been an expert in Earth's atmosphere. Can you tell us, or start by telling us, how we study Earth?
Yeah, so I mean, humans have been studying Earth ever since we lived on it, looking up in the skies and studying what's around us. But there's only so much you learn that way. And now that we have the ability to go to space and study Earth with satellites, you can see the whole global picture over the oceans, all the lands, and really see how things are connected. And I'm going to tell you just a second a little bit about carbon dioxide. This is a map of a model field of carbon dioxide showing you how dynamic it is, how quickly it moves around. And you also can guess from this that carbon dioxide is emitted by humans. When we burn fossil fuels, we put it up in the atmosphere. And I mentioned it's a blanket capturing heat. So when we put that up in the atmosphere and the amount increases, it keeps us really warm. But carbon dioxide is also it's dynamic with other parts of our Earth. The plants in the Earth take up carbon dioxide, remove it from the atmosphere, release it when the leaves fall off. And so there's this big dynamic natural carbon. To understand and pull these pieces apart and see why each year can be a little different in the carbon cycle, we're using satellites to do that. We have one in space now called OCO2. It's been up there since 2014, but this is a cool little scale model. This is a model 1/10 in size. The real thing is about the size of a big refrigerator. This is a payload that's going to go up on the International Space Station called OCO3 to continue our carbon dioxide measurements.
And that's supposed to go up soon, right?
A week from Tuesday, April 30th.
Oh, look out for that, all of you out there. New launch.
Yeah.
All right. So we've talked about a little the carbon area, but there's also the water cycle, which is super important. So can you tell us how we study Earth?
So we use satellites, airborne campaigns, and ground instruments to study water. Water is abundant on Earth. Approximately 71% of the Earth's surface is covered by water. However, less than 3% is fresh water, meaning potable or suitable for drinking. And of this, less than 3%, 2/3, is locked up in ice caps and glaciers. So fresh water is rare. We have satellites like SMAP, which is soil moisture active passive, GRACE, which studies groundwater, and Landsat, whose data can be used to study evapotranspiration. We conduct airborne campaigns like SNOWX and ASO, Airborne Snow Observatory, which collect data on snow water equivalent and snowmelt. And this data is important. It helps improve water management and it guides policies. For example, more than 1.5 billion people rely on snowmelt for its water supply.
All right, you mentioned that NASA has this airborne snow observatory, and 1.5 billion people is an enormous number of people. So, I mean, that's new news to me. I had no idea we relied so much on snowmelt. And we even have some footage from one of the recent campaigns from the field. So let's take a look at that.
ASO is a partnership between NASA JPL and the California Department of Water Resources. ASO operates in 2 states right now in western US. We operate in California and in Colorado. And we're here to measure the snowpack, to provide information to help us manage our water resources. ASO tells us 2 really great things about the snowpack. The first one is how much snow water equivalent is up in the mountains. And the second is how reflective or how shiny that snow is. And so those 2 things tell us, 1, how much water we have for our drinking water, for irrigation. How reflective it is tells us when it's going to melt from the mountains. We have 2 instruments on board that look through the bottom of the plane at the snowpack. The first instrument is a giant laser pointer. It's a scanning LiDAR. The second instrument is an imaging spectrometer, which is a fancy camera. With the airborne platform, we can touch every piece of snow with our LiDAR. Right now, we are delivering information directly to the California Department of Water Resources, and that helps them decide where to put water, when to make releases from dams, and how to allocate those resources more efficiently. It's amazing to be flying on this plane in the mountains. At 20,000 feet, you get an epic view of the watersheds. You get a really great view of the snowpack and how it's distributed. And as a scientist, I really love sitting up there and thinking about how I can understand the snowpack more. I start off in the spring working very long days, making sure that everything is going smoothly, but it's really worth it at the end to be able to give that data to the folks that need it so that we can improve our lives and manage our water resources more efficiently.
All right, I hear that some of you are wondering about our NASA Spinoff technologies. So if you are excited about learning about NASA Spinoff technologies, you can visit spinoff.nasa.gov to learn more. So back to our video stuff. I had no idea before we started the show that so many people relied on snowmelt as a source of drinking water. And it really is incredible how our Earth systems are just so connected to provide us with these really precious resources. So we've been talking a lot about what makes Earth special, but that doesn't mean that it's only Earth that has some of these amazing resources, like atmospheres or volcanoes and even seas. So yes, Earth is pretty weird, but our scientists here at NASA see some of Earth's distinctive qualities elsewhere in the solar system, and really even beyond. So let's take a look at some of the other bodies in our solar system that share some of these features with our home planet. So viewers, this is where we need your help. This is a photo of an atmosphere on another planetary body. Where do you think it is? Type your answers in wherever you're watching this. So is this atmosphere A, Mercury, B, Pluto, or C, the Moon? Another atmosphere. Is it A, Mercury, B, Pluto, or C, the Moon? And the answer is B, Pluto. So what's the difference between this atmosphere and Earth's atmosphere?
So this is an atmosphere you and I would not breathe very well in. It's made up of different types of gases. It has nitrogen in it, and it has some hydrocarbons. Methane is a good example of one of those. It also disappears and reappears almost completely because it condenses out and then goes back up. So it's a very different kind of atmosphere than we have here at Earth.
All right, let's get on to another question. There are volcanoes on other planets too. So where do you think that this volcano is in our solar system? Is it A, Venus, B, Saturn, or C, Mars? Another volcano. Is it Venus? Is it Saturn? Or is it Mars? And the answer is C, Mars. Yes. All right, so how do the volcanoes on Mars compare to the ones on Earth?
So this volcano is called Olympus Mons. It's the biggest volcano we've discovered in our solar system. Literally 90,000 feet high. It's as big as France. One volcano. 5 million cubic miles of rock. It is many times bigger than the closest analog on Earth is Mauna Loa in Hawaii, and its other cousin big volcano is Mont Mons on Venus. So this is the granddaddy. When this volcano erupted, it produced enough gas to fill the Mediterranean Ocean with water.
Oh, look at that. All right, so there are other seas on planetary bodies too, but they may not be made out of water. So where do you think that these seas are? Is it A, Saturn's moon Titan, B, Jupiter's moon Europa, or C, Mars' moon Phobos? Is it Titan? Is it Europa? Or is it Phobos? And the answer is A, Saturn's moon Titan. Now, are these seas on Titan similar to the ones on Earth?
They're very different. These seas are made of hydrocarbons, and they freeze from the bottom up. And we're seeing them through the eyes of radar flying on a satellite known as Cassini that maps Saturn and its moons, and that allows us to connect a world bigger than our moon, Titan, to our own planet. This is spectacular connectivity between our planets and other worlds.
Ooh. So, did any of you guys get those at home right? We still want to hear from you, and our scientists are ready to answer some more of your questions using that hashtag AskNASA. So, let me see what has come up through my little iPad here. All right, Zachary on Twitter is asking, how did Earth cool down?
Well,
Sounds like another gym question.
so our planet was big and born hot, but eventually, through processes in which heat flows out by conduction and convection, the planet cooled down. But today, the planet's still pretty warm, and we have tens of thousands of miles of undersea volcanoes, the mid-ocean ridges, that help get rid of that excess heat in our planet. But while that's happening, which helps keep our planet nice, while that's happening, the planet's regulating itself inside. And so that's what makes Earth so spectacular. We have action everywhere.
All right. Susan on Facebook is asking, is there evidence of other planets' cores that used to behave like ours?
Well, we did detect the sign of a relic magnetic field on Mars with the Mars Global Surveyor, and that mission suggested that the early Mars geomagnetic field may have been the same size as Earth's. But then something happened. Mars managed to lose its internal magnetic field. So how do you do that? I haven't lost a magnetic field yet. So we need to understand that. That also has consequences for Mars' atmosphere and even for its ability to sustain life today. So a good analog for Earth. Let's watch Mars.
All right. And then Zachary on Twitter is also asking, how big is the ozone hole and has it changed?
Wow, that's a great question. So the ozone hole, I don't have a number in terms of square miles, but I can tell you it's not as big now as it used to be. So for those older folks in our audience, you remember those aerosol spray cans? No more of that. We got rid of the CFCs. We've changed a lot of what we produce, and it's had an effect. We're starting to see the repair of the ozone hole.
All right, Kristen on Facebook is asking, what are some of the things we can do to help nurture our planet?
Well, I have a few ideas. One thing we can all do is just buy less stuff. The less stuff we buy, the less has to be made, so that's good. And I'm a big fan of a bicycle. In Southern California, you can bike a lot of places and not get caught in the rain, so it's one thing I do to reduce my driving.
And along those lines, you look at conservation of our natural resources like water and other things. So.
And plant trees.
Yes.
Yeah, tree,
yes,
that's a
true.
great idea.
Sorry.
Yes, Scott already told us to do so.
Scott, you're listening to Scott.
All right, Alicia, we have another question for you, which is how do satellites track the movement of water?
Well, we use satellites to track the movement of waters in various ways. We have several satellite missions that are currently up. For example, we have SNAP, as I mentioned, which is soil moisture active passive, and we track soil moisture using that. We have the GPM, which is the global precipitation measurement, and we use that to track precipitation, water that falls from the earth, and ice. We have missions like ICESat and upcoming SNOWX and the ASO, which we use to track the ice and snow in our atmosphere and on the surface of the earth.
I'm glad we're doing so much to do that. All right, Beverly on Facebook is asking, how does global warming affect Earth?
Wow, Wow, that's a long answer, so I'll give you a couple of ideas, and I'm sure the others have more to share. So one of the first things we want to say is that the temperatures have been increasing. We can see that in the temperature record, the fact that many times we see we're the hottest year on record recently. The ice sheets are another place, and the sea level, we see the sea levels increasing, and that ice sheet area is shrinking a bit. So those are all impacts about these warming temperatures.
I mean, we're seeing the total ice cover of the planet changing profoundly. Things we didn't see exposed are now being exposed. Edges of an impact crater in Greenland have now been exposed. We're finding airplanes from 50, 70 years ago that were buried in ice that are popping up, just showing some of those consequences.
All right. So that is all the time we have for questions today, but don't worry, we'll be answering more of them on social media after the show. So thank you for participating and sending them in, and please just keep sending them in. So we've learned a lot of things about Earth today. We've got liquid water, a protective atmosphere, and an active core. And yes, they exist elsewhere, but on Earth, the combination of features come together in a perfect balance, and it gives us this oasis in space. So scientists, considering that, what, in under 5 words, are your favorite things about Earth?
For me, a snowy day on a mountaintop.
Our spaceship Earth is like an island in space, and I love the islands we see, which are kind of mimicking how our planet is.
And I love the regenerative properties of the Earth. The Earth heals itself.
That's wonderful. What is your favorite thing about Earth? Tell us in the comments, and let's hear from some other NASA scientists about what they have to say.
Earth is my favorite planet.
My favorite part about planet Earth is the ocean.
So my favorite part about Earth is there's life here. We know that there is life here. There's so many aspects of it. I mean, the very fact that we're here.
My favorite part about the Earth is the Arctic.
That feeling before a thunderstorm.
I enjoy the feel of the wind.
When you fly, when you are on an airplane, and you are in between 2 decks of clouds.
There are so many different environments on Earth that we are just now exploring in the past few decades.
It actually floors me that we have such a large area on this planet that is, basically relatively unexplored.
The depths of the ocean.
To see that life flourishing under the water.
I think that's fantastic.
I feel like the best thing about planet Earth is that it's so close to the moon, and the moon is awesome.
That the Earth has a large moon that keeps its climate stable by keeping its poles stable.
Coming back up to where does our atmosphere end?
The feedback between life and our climate.
How far out can microbes live?
I like how sunlight interacts with Earth.
How that influences the sea ice.
I just love the diversity of life on Earth and all of the places that it can thrive. It's pretty amazing.
And my favorite thing is carbs, sugar, butter, chocolate, and bread. Well, happy Earth Day, friends. Thank you so much for joining us. Next month, we're going to take you on a tour of storms across the solar system. So we'll see you all next time. Thank you all also.
Bye-bye.